Hello, everyone. So today we'll be presenting our research on what kind of peer assessment comments help improve learning outcomes. Regarding this research, I hope that people agree with these two things. So number one is people learn from discussing with each other while doing projects. Number two is that some discussions are valid and beneficial, but it's probably not always the case. But surely we could encourage students to do more discussions, to review each other's work and talk about them. But wait, they could actually be saying anything. So before we start to encourage them to do more peer assessment, maybe we should take a step back and figure out how efficient this is and what factors shall we be looking at if we were to promote this. But one thing we found is if you only promote the quantity of discussion, it has nothing to do with the quality or the impact of it. So peer assessment is a form of discussion mentioned before. It benefits students if it is done in a timely manner with quality and personalized components. TAs instructors, we simply don't have as much time as students to review everyone else's work. If we have to review, we'll have to review hundreds of students, and we could probably not do a good job in personalizing them. And having students doing peer assessment benefits the assessor and SSC at the same time. And since this is a metacognitive process, students receiving these assessment comments will learn from it if they process it in their mind. But moreover, people who's writing that comment needs to go through a lot more steps. They have to understand the artifact being reviewed. They have to use their knowledge to find problem in the artifact. And then finally, they have to give suggestions in a way that's acceptable by reviewees, the receiver of comments. So by blindly promoting discussion, promoting this peer assessment process, it is likely that people are going to receive comments such as these: "Good job, they know it," and as we discussed in the second slide, this kind of reviews only will raise the quantity of the comments they receive. It has nothing to do with the action they take after receiving them. So different researchers has different opinions. Different researchers have different opinions on what categories are there in terms of peer assessment comments. So one researcher has mentioned there are 4 categories: those that points out a problem, that gives a solution, that recognize your work positively, and that explains things. And the other another group of researchers has categorized it in a very similar way. Reviews that helps understanding the problem, reviews that helps people accepting it. For example, is the work being recognized? Is it positive? Is there a problem statement, solutions, such and such? So we put review comments into 3 broad categories: reviews with problem statements, with suggestions that are positively praising people's work. But there's always the debate among different researchers that these characteristics will have different effect. One group of researchers mentioned that giving solutions promotes betterments while pointing out problems. Yeah, it does that, but not significantly. And having reinforcing comments is probably not going to do anything. While the other group has a very different opinion. They think that having this reinforcing feedback is more important. It promotes the quality of students' work. As contrary, pointing out problem is harmful, and giving suggestions is merely important. So back to our research. Our research is to find out what really happens. Our research is done in a computer science class that's open to computer science students and also electronic engineering students. And on average, 3/4 of the students receive an A, and we believe reading and writing peer reviews have played a positive role in this process. So the format of assignment done in this class is in the form of coding an open source software project. And then students are going to submit the code onto GitHub, having their peers do a round of formative review, and then another round of summative review, and make revisions in between these 2 rounds of reviews. So we're going to research that how is that round of formative review given before the activities of revision? How is it? What kind of impact does it have on students improving their work? So students will form teams first, submit their artifacts, submit the project, and then other student teams will come and review it. And then they'll make the suggested changes, hopefully. If we use one team as an example, this student team will write code, push it onto GitHub, have a bunch of other student teams come here, read the code, give comments, and they'll read a comment, update their code and push it onto GitHub. And this is the formative stage. The summative stage is just having the same group of the other teams come here and review your code and give a grade. So what I mean by effective, we measure the effectiveness by improvement through looking at several GitHub metrics. So we compare this metrics before and after they receive the formative round of reviews. Things we look at are number of commits, number of lines added, deleted, files changed, total number of lines changed, and the delta. The delta is defined as the number of lines added, deducting the number of lines deleted. And later we'll see why it makes sense. We collect this data through looking at people who submit the assignment, looking at that project and find collaborators, and then coming up with the aggregated count on the statistics done on GitHub. So when talking about reviews, students will give review. We have an interface for students to give each other reviews. They'll be able to write reviews, give star ratings, and then receivers will be able to see the review, whether it's rubrics designed towards the non-coding part or the coding part. As instructors, we can see all of them. We can see an aggregated interface on who received what review from whom on what metric. So to fit this review comments into categories, we formulate this into a text classification problem and onto 3 different semantic components: positive sentiment, problem statement, and suggestion. We did it through a number of different techniques in classification, and we believe that our audience should know almost all of it. There's the classical approaches such as decision trees, random forest, vector machine. There's neural network approaches, text CNN, STM. Then there are models utilizing attention mechanisms such as BERT. And there are also tricks in training them. For example, you can train them with multi-label training so that you train one model with 3 different labels. And surely, the classical methods, the classical methods are not necessarily bad. But in our experiment, we do find that newer methods, such as using BERT, trained in multi-label fashion, gives us best performance. But later, we'll associate the reviews received in each category, associating that with the GitHub metrics we collected before and after receiving these reviews. And we find that when more problems are brought to students' attention, we see a weak to moderate correlation between it and the number of commits, well, presumably on fixing problems mentioned in the comments, and a weak to moderate correlation between that and delta in code. The reflected correlation on delta makes sense. If you think about it, updates on existing code almost always involve removing code and then the code that's problematic, and then adding new code to correct it. And adding missing feature always involves adding code in there. And we also found that, on the other hand, when presented with positive reviews, there's a moderate negative correlation on that and the revision activities. The greater the percentage of positive reviews, the lesser modifications done to the project, measured either in delta or in the number of files changed. While other types of comments revealed weaker correlation with any of the GitHub metrics, so we're not going to discuss that over here. The differences between our finding and findings in prior research is, number 1, does positive review reinforcing feedback trigger revision? Not so. And does corrective feedback with problem statement, does it hurt or promote students' motivation? We found that it is positively promoting students' motivation on making revisions. And suggestive feedback, does it encourage or discourage students to make changes? Well, it is not. It is not the best thing, as mentioned by one researcher, but it's not completely useless mentioned by other researchers. It is in the middle of it. It has a weak positive correlation with the metrics we collected. So there are a couple limitations in this work. Number 1, it is done on a single class in computer science, and our measurement of improvements are solely based on GitHub metrics. There could be a lot of other metrics that we can use to measure that, and we're not even sure that we could associate them with the effectiveness of comments. So if not much changes are observed on GitHub, other factors could it be, could it be because the work being reviewed are already with good quality, or could that be a reason of why positive reviews show negative correlation with code changes? Or could there be, the review you can understand, like the ability to understand the comments? Or could it be, we counted the same problem statement for too many times if they're made by different reviewers? If it's towards the same problem, maybe we should just count it once. So if you have any questions, comments, concerns, you're very welcome to reach out and get into contact with the authors. I'm the presenter, Yunkai, and you may also contact other authors participating in this research regarding their expertise.